Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is conditional probability. When finding a conditional probability, you will be finding the probability that an event A will occur, given that another event B has occurred. So in this video, we will look at the notation for the conditional probability, and let's see how to find the conditional probabilities with a table or with a formula. First, let us see what is conditional probability. Suppose you have to calculate the chance of a person meeting with a road accident. You also have information regarding his driving skills. This information can be used to show a relationship between these two events. So we can say if a person drives well, there is less chance of him to meet with an accident. This information of good driving skills put a condition on the chances of meeting with an accident. So this is an example of the conditional probability. This probability shows that the chances of occurrence of some events for which some other events of the random experiment has been already occurred. The occurrence of an event is related to one or more events. This is nothing but the occurrence of some event based on the previously available sum of the information. That information can be used to calculate the probability of some new events. Okay, here is the formula to calculate the probability of event A for which event B has been already occurred. It is denoted by probability of A given B. And its formula is probability of A intersection B over probability of B. Please note that probability of B is not equal to 0. So this is the formula for conditional probability. This is the common notation for conditional probability. You can think of the line as representing given. On the left is the event of interest, and on the right side of the bar is the event that we are going to that we are assuming that has been already occurred. A is what we are trying to find, and B is what we already know. So you can read this as probability of A given B. So with this notation, you can also use words to describe the events. For example, in case if it is a word problem, let's say we wanted to find the probability someone buys a new car when you know they have started a new job. So this can be represented as, I'm going to write the same notation using words by taking an example. Probability of the event that we are going to find buys a new car, that we already know. Probability of buying a new car given started a new job. Okay, let us see an example for conditional probability using a table of data. Here is an example. A survey asked full-time and part-time students how often they had visited the college tutoring center in the last month, and the result is given in a table form. This question asks us to find what is the probability the student visited the tutor center 4 or more times, given that the student is full-time. So for this type of probability questions, you can see this word given. Something, we are asked to find something given that something has happened. So for these types of problems, you can look at the results given in the two-way table. Please look at the table. Here, conditional probability is all about focusing on the information you know when calculating this probability. We are given that the student is full-time. Therefore, here we should look only at the full-time students to find the probability. This one, this row, 12, 25, 8 and 45. So in this question, we are supposed to find probability of 4 or more times given that the student is full-time. Under this condition, under given condition, we are supposed to find this probability. So here 4 or more times is for full-time student is 8, and total for this one, total number of possible outcome is 45. So 8 over 45. You can give your answer either in fractions, decimals or percentages. Hope you're clear with part A. Okay, let me add one more part for this question. Suppose that a student is part-time. What is the probability that the student visiting the tutor center 1 or fewer times? Okay, this one is a bit more tricky due to the wording. So think of it in the following way. We are supposed to find probability student visited the tutor center 1 or fewer times. And you can assume that the given condition here is student is a part-time. Suppose that the student is a part-time. Since we are assuming or we are supposing that the student is part-time, we can look at the part-time students for this calculation. This one. And 1 or few times is 2. And the total is 13. So if you divide this one 2 over 13, it is approximately equal to 0.15. So whenever you get word problems, read the question carefully, because you have to identify the correct thing, what they are asking you to find, and what is given actually that has been already happened. Okay, let me take one more question for the same table. Here is the next part question. If the student visited the tutoring center 4 or more times, what is the probability he or she is a part-time? Please read the question carefully and find what we are finding and what is given. Here we are supposed to find that the probability he or she is a part-time, and it is given that you can assume that what has already happened. The student visited the tutoring center 4 or more times. If the student visited the tutoring center 4 or more times. Okay, for this question, we are only looking at the students who visited the tutoring center 4 or more times. So instead concentrating on the row, you have to work out this column 4 or more times. And particularly the students that those who attend the college part-time, 6. So 6 over 14. The same probability formula, total number of favorable outcomes over total number of all possible outcomes. The thing is, you have to identify the question carefully. Identify what is to be found and what is already given. So here the question, let me rewrite the same thing in notation form. Does this make sense to you? Okay. So this is an example with a table. Let me take few examples using the formula to find the conditional probability. In some situations, you will need to use this formula to find the conditional probability. This formula could actually be used with the table data, though it is often easier to apply in problems similar to the example that I am going to take now. Here is an example. You toss a fair coin 3 times. What is the probability of 3 heads? That is the occurrence of H. What is the probability that you observe exactly 1 heads? Okay, let us solve this question part by part. We assume that the coin tosses are independent. So probability of this getting H, 3 heads. According to the formula, if they are independent, the formula is going to be result for tossing a coin is 2 outcomes. Only 2 outcomes are possible. You either may get head or you may get a tail. So getting a head would be 1 out of 2. And the same thing for both. 1 out of 2 times 1 out of 2 times 1 out of 2. By fractional multiplication, you'll be getting 1 over 8. Hope you're clear with part A? Okay, let us do part B. What is the probability that you observe exactly 1 heads? So to find the probability of getting exactly 1 head, we can write this as, for this one you have to apply probability of getting 1 head. So probability of HTT, THT, TTH. So finding the probability is very easy for this one. 1 over 8 plus 1 over 8 plus 1 over 8. Okay. Let me take one example for the conditional probability where the formula can be applied directly. Please look at this example. Your neighbor has 2 children. You learned that he has a son, Joe. What is the probability that Joe's sibling is a brother? Okay. The obvious answer that Joe's sibling is equally likely to have been born male or female suggests that the probability of the other child is a boy means it is 1/2. Actually, this is not correct. So consider the experiment of selecting a random family having 2 children and recording whether they are boys or girls. So the sample space, the total number of possible outcomes would be maybe boy boy, boy girl, girl boy or girl girl. Okay. This outcome BG means the firstborn child is a boy and secondborn is a girl. All the first alphabets are firstborn and second alphabets are secondborn. So these are the total sample spaces, total possible outcomes. Assuming that boys and girls are equally likely to be born, the 4 elements in the yes are equally likely. Therefore, the event E that the neighbor has a son is the set E. So the event is occurrence of boys. I am taking only the outcomes that has boy in it. The event F, let the event F be the neighbor has 2 boys. Okay, that is Joe has a brother is a set F. Generally, I used to take E and B. As already we are using these alphabets, I am taking events E and F. Okay, now let's find the conditional probability. Okay, here is the conditional probability formula. Probability of F over E. F given E is probability of F intersection E over probability of E. Please notice that whatever event comes in the denominator will come in the denominator of the right side too. Okay, this is a keyword to remember the formula. F intersection E. So is there anything common? BB. Yes. So 1 out of 4. Probability of E is total number of outcomes in E is 3 and total number of outcomes in the sample space is 4. So 3 out of 4. So the conditional probability here is 1 over 3. Conditional probability is different from other probabilities in that you know or you'll be assuming that some other event has been already occurred. Therefore, when you calculate the probability, you must narrow your focus down to the known event first. If you're given a table of data, this means focusing only on the row or column of the interest. Hope you remember the formula that we just discussed. Okay, with a formula, this means that the probability of the known event will be in the denominator. Denominator